Hello guys, in this video we are studying a very important topic which is LC oscillations, and this topic is very important as far as IIT Advanced is concerned. So I am explaining you this complete topic with a comparative illustration with spring block system. So starting that this is an inductor and this is a capacitor, and this switch is S1 and this switch is S2, and this is a cell of EMF V. Now initially this cell is charging this capacitor completely, and this switch S2 is closed and S1 is kept open. So when this S1 is kept open and S2 is closed, then in that situation this cell would completely charge this capacitor with this polarity, with the plate A as positive and plate B as negative, and the total charge Q naught, which would be appearing at the end of the complete charging, would be CV. We know that Q is equal to CV. So this is the initial system, and to start the circuit of LC oscillations, we have to connect this switch, we have to disconnect the switch S2 and we have to connect the switch S1, but this would be done on the next page. I am comparing this circuit with the spring block system, and we know that to start the spring block oscillations we have to compress this spring, and then we can release this spring to start this spring block oscillations. Now we can easily compare that in LC circuit we have given the initial energy to capacitor, and in a spring block system we have given the initial energy to the spring. So clearly I am comparing this capacitor with spring. So I am writing the first comparison in this analogy table, that I am comparing capacitor with spring. Okay, so the initial energy which I have given to the capacitor is half Q naught square by C, and the initial energy which I have given to the spring is half K x naught square. So you can also compare that this 1 upon C is comparable to K, and this Q naught is comparable to x naught. Okay, so the initial energy which is given to this capacitor is being stored in form of electrostatic potential energy, we all know, and this initial energy which is given to this spring is being stored in the spring potential energy. Now this Q naught is the maximum charge here and x naught is the maximum compression here. Now initially this inductor is being uncharged and this mass does not have any kinetic energy. So I am comparing this inductor with this mass M, obviously, and this Q naught is the charge, so dQ by dt should be the current, and hence I am comparing this Q with x, so dx by dt should be the velocity. So I will compare the current with velocity. Now starting the oscillation. To start the oscillation, we are connecting this capacitor alone with the inductor, and we are releasing this spring. So at t is equal to 0, switch S1 is closed and S2 is opened, which means that this capacitor is being connected alone with this inductor. And similarly in this section of a spring block system, at t is equal to 0, this block is released. Now as time will progress, this capacitor is transferring its energy to the inductor, and it is acting like a cell, and it is giving a current I, you can see that, and as the time will progress the capacitor would be discharged and inductor would be charged. Now, if the capacitor is discharging, then its charge would be decreasing, and obviously inductor is charging, and the energy stored in the inductor is half Li square, and we can say that this energy depends on the current, and if this energy is increasing, then current must be increasing. So this current flowing through the inductor is increasing current because it is charging up the inductor. So the polarity of EMF which would be developed across the inductor would be in according to this increasing current, and hence this EMF will oppose the incremental nature of this current. And to oppose the increasing current, the EMF would show the positive polarity to the incoming current. Therefore, this polarity would be seen on the inductor. And at any instant of time, let's suppose the circuit has some current I, and the charge on the plates of the capacitor is Q. So the inductor has an energy of half Li square, and capacitor has an energy of half Q square by C. But this energy which is given to the inductor is a part of the energy which was initially stored in the capacitor. So the sum of these instantaneous energies of inductor and capacitor should be equal to the initial energy which was with the capacitor. Now similarly, in a spring block system, we are compressing the spring and we are releasing it. Now spring like capacitor is starting to transfer its energy to this mass, and this block will start to move. So at some instant of time, this spring would be compressed by a lesser amount as compared to initial one, and hence this energy released by the spring is being transferred to this mass in form of kinetic energy. So at this instant, the spring has an energy of half kx square, and this block has a kinetic energy of half mv square. But the sum of these two energies should be the initial energy which was stored in the spring. Therefore, us plus k is equal to half kx naught square. So you can see that I am comparing this energy of inductor with this kinetic energy of the block. So I can write here that the energy of inductor UL is compared with the kinetic energy of this block. Okay. So at time T by 4, capital T by 4. Now you would be wondering that what is capital T. So this system is in the state of oscillation, as I am comparing it with the spring block system, and all of you know that a spring block system is a oscillating system. So this time period T is the complete time period of the LC oscillations, and I would explain that how it works and how it makes sense. So I am talking about the T by 4 instant of the time. So at this time, the capacitor has completely transferred its energy to inductor, and hence the current in the circuit would be flowing to its peak value, maximum value, and the charge across the plates of the capacitor would become 0, and the complete energy is being transferred to the inductor. Therefore, energy stored in the inductor, which is half L I naught square, will be equal to the initial energy which was with the capacitor. So I naught can be calculated easily by this relation Q naught upon under root LC. So this is the value of I naught. And in this side, on the spring block system side, this spring is relaxed and this block is passing through its mean position, and hence this block will have a maximum velocity, and its velocity can be calculated by equating the energies. That this block has some kinetic energy half mv square at this instant, and this energy has been transferred by the spring, and the initial energy of the spring was half kx naught square, and obviously at this position spring is relaxed and its complete energy becomes 0. So V naught is equal to under root of k by m into x naught. This is the velocity, and if you can visualize that I am comparing this x naught with q naught, and I am comparing this v naught with I naught. So therefore we know that 1 upon c is comparable to, I will write it is comparable to k, and L is comparable to m. And we also discussed in the previous videos that the self-inductance is also known as electromagnetic inertia, and obviously mass is the representative of inertia. Now in the as the time will progress, after the time t by 4 and at the time which is less than t by 2, in that period of time when the time is between t by 4 and t by 2, now the inductor would be giving its energy to the capacitor, and it is very important to note the polarity. You should see that throughout the time when capacitor has charged this inductor, the polarity of the inductor is in such a way such that at the left hand side it is positive terminal and at the right hand side it is negative terminal. But now when inductor is charging the capacitor, now the inductor is giving its energy to the capacitor, and hence the current which would be flowing in the circuit would be decreasing, because the energy of the inductor is decreasing and the energy of capacitor is increasing. So the current is decreasing, and the polarity of this inductor and the polarity of, in fact, EMF of the inductor would be decided by this decremental nature of the current. So to support this decreasing current, the polarity would be reversed, and the positive terminal would be now at right hand side and the negative terminal would be now at the left hand side. And therefore as this inductor would be acting as a source of voltage for this capacitor and a battery for this capacitor, therefore the positive terminal would be appearing at this side of the capacitor and the negative terminal would be at this side, and the charge of the capacitor would be increasing. So now obviously in the case of spring, this block will move away from its mean position and it will stretch the spring, and if the spring is being stretched by the block, then it will spring will have some potential energy, and that potential energy has been transferred by that block by the virtue of its kinetic energy, and a part of its kinetic energy would be transferred to this spring, and the velocity of this block would be decreasing now, and the extension of this spring would be increasing now. Now exactly at t is equal to t by 2, this inductor would completely give its energy to the capacitor with reversed polarity, and the current in the circuit would become 0 and the charge would become maximum. And again the total energy of the capacitor would become same as it was earlier at t is equal to 0, but the polarity of the charge is reversed. And similarly in this case, in the spring block system, the spring would be stretched by the same amount as it was compressed initially, and that was x naught, and the velocity of this block will be 0 at this instant of time, and therefore the kinetic energy of the block would be 0 and the spring potential energy would be half k x naught square. Only the difference which is the fact that the polarity of the capacitor has been reversed and the spring was initially compressed and now it is being stretched. Now as time will again progress from in the period of t by 2 to 3t by 4, in this period the capacitor would again be acting as a source of potential for the inductor, and it would be charging the inductor by flowing this current, and this current would be increasing current because now inductor is being charged, and therefore similarly this spring will pull back the block and it will again, spring will again transfer its energy to the block in form of kinetic energy. Now exactly at 3t by 4, the capacitor has transferred its complete energy to the inductor, and now the current in the circuit would become again maximum, and the charge of the capacitor would become 0. And similarly, the block is again crossing its mean position, but in different direction, in exactly opposite direction, and the maximum and the kinetic energy of the block becomes maximum, and the spring energy becomes 0. Now in the period of last quarter, which is 3t by 4 to t, now the inductor would be acting as a battery, and it would be transferring its energy to capacitor. But again, you have to notice the polarity. That initial polarity was the fact that positive terminal would be at right hand side and negative would be at left hand side. But as the inductor will charge the capacitor, the current flowing through this circuit would be decreasing, because now energy is being transferred from inductor to capacitor, and hence the current in the circuit would be decreasing and the charge flowing through the capacitor would be increasing. So this inductor would have a polarity of EMF in such a way such that it would support this decreasing current, and to support it, it would show this positive terminal to this outgoing current, and therefore the polarity would be reversed as compared to the previous one. And now in this case, this mass passing through that this position, mean position, it is compressing the spring, and it is transferring its kinetic energy to the spring in the form of spring potential energy. Now finally, at the last instant of time t, which is capital T, which is the complete time period, the inductor has again given its complete energy to the capacitor, and you can notice that this polarity of the capacitor is the same polarity at t is equal to 0. So this initial condition of the capacitor and inductor is regained, as initially the inductor has 0 energy and capacitor has half q naught square by c energy with this polarity, and this condition has again been restored, and therefore we are saying that this time at which this initial conditions are restored is called as the time period of the circuit. And again, in the spring block system, this block has completely compressed this spring, and that complete compression is x naught, and the velocity of this block becomes 0. And again, this is the initial condition from which we have started the spring block oscillations. So I have written that cycle completes as initial conditions are restored. So this was the complete comparative analysis of spring block system, and you can see that in LC oscillations what is happening, that is capacitor is charging inductor and inductor is charging capacitor. So the transfer of energies, or we can say the energy is oscillating from inductor to capacitor and capacitor to inductor, and the current and charge is oscillating. Now further, we will do the mathematical analysis in this video of this LC oscillations, and we will also find out the equations of current, oscillating current, and charges. Now moving further. Now coming on to mathematical analysis of LC oscillations, you can see these inductor and capacitor are connected in parallel to each other always, and let's suppose a situation in which this capacitor is charging the inductor. Therefore the current I is increasing and the charge Q is decreasing, because this capacitor is charging the inductor, and the current in the inductor would be increasing as its energy is increasing, and the energy of the capacitor is decreasing, therefore its charge would be decreasing. Now we know that the EMF across the inductor is L di by dt, and if I'm taking the magnitude, then I will take positive, because di by dt is also positive as current is increasing, and the potential across the capacitor is Q by C. So we can say that E is equal to Vc, because these two are connected in parallel, and L di by dt is equal to Vc. Now this di by dt. Now I can write down the current as minus dq by dt. This negative sign represents the fact that this charge is decreasing with time. So dq by dt would be negative, and hence di by dt will be equal to minus d square q by dt square. Now putting this value in the equation 1, we can see that L into minus d square q by dt square is equal to q by c, and this q by c is equal to, in fact, q by c plus L into d square q by dt square is equal to 0. Taking L common, then I can write q upon LC plus d square q by dt square is equal to 0. Now you can analyze that this is the equation of a simple harmonic oscillation, and by comparing it with that equation which is for SHM, for simple harmonic motion, the equation was d square x by dt square plus omega square x is equal to 0. Now I am comparing this x with q, and the rest will be compared. Therefore omega square, in this case comparing with this one, omega square will be equal to 1 upon LC, and omega will be equal to 1 upon root LC. Now you can see that omega is 2 pi f and it is equal to 1 upon root LC, while f is equal to 1 upon 2 pi under root LC. So this is the frequency with which this charge and this current will oscillate in this LC oscillations, and this is the equation of oscillation for this LC system. Now the general solution of this equation, the general solution of this equation, this one, is q is equal to q naught sine omega t plus phi. Now we have already calculated this omega, and q naught was the maximum charge which was present on the plates of the capacitor initially. So we just need to find out this phi, which is the phase, initial phase. So we can apply the boundary condition of the initial case, that at t is equal to 0 initially, the charge was equal to q naught. It was equal to the maximum charge, and hence at t is equal to 0, q was equal to q naught. So therefore this q naught will be equal to q naught sine phi. So phi will be equal to 90 degree. So which means that q naught is equal, in fact q is equal to q naught sine omega t plus pi by 2. So this is the equation of charge which is oscillating in this system, and q is equal to q naught sine omega t plus pi by 2. This is equal to q is equal to q naught cos omega t. So this charge is having an equation of q is equal to q naught cos omega t, while if I find out the current, then I can write that I is equal to minus dq by dt. You should not forget this minus sign, because when the current will increase, this charge will decrease. So I is equal to minus of d by dt of q naught cos omega t. So I is equal to, the differentiation of this cos omega t will be minus sin omega t. So it is minus q naught omega sin omega t, and this term will be the maximum current. So it is minus I naught sin omega t. So this is the equation of charge, this is the equation of current. The energy stored in the capacitor at any instant of time will be half q square by c, and the energy stored in the inductor at any instant of time would be half L I square. So UC will be equal to half q square, which is q naught square cos square omega t divided by c, and UL will be equal to half, I will write it down here, that UL will be equal to half L into I naught square, which is I naught square sine square omega t. So you can see that the energy stored in the capacitor is the function of cos square omega t, and the energy stored in the inductor is the function of sine square omega t. So if we move on the graphical analysis, then we will see that the charge was a function of cos, so q was equal to q naught cos omega t. The current was represented by the equation I is equal to minus I naught sine omega t. You can see that this graph is a graph of minus sine omega t. The energy stored in the inductor was the function of sine square omega t. So this is the energy which is the function of sine square omega t, and the energy stored in the capacitor is the function of cos square omega t. So this represents the graphs of all four quantities. So you can easily compare this LC oscillation with spring block system, and I have already written the complete analogy of both the systems which are oscillating. You just need to remember that the frequency here is equal to 1 upon 2 pi under root LC, the frequency of oscillation of this LC system. And also in the upcoming chapters of electromagnetic waves, I will explain that this LC oscillation is also the source of electromagnetic waves. I will tell you how in that chapter. So thank you.